want to prove two triangles are similar. Okay, one of the ways that we can do that is by using what's known as AA similarity. So I am going to draw two triangles. One of them I will label as A, B, C. The other one D, E, and F. Okay, so I can say that triangle ABC is similar to triangle DEF if I can show that two angles from one triangle are congruent to two angles of another triangle. So it goes back to what we just talked about with the corresponding angles being congruent. But you don't have to show all of them, you only need to show two of them. Okay, so if I could show that, say, angle A is congruent to angle D, and if I could show that, say, angle B is congruent to angle E, that's enough to show that the two triangles are similar by the AA similarity postulate. Okay? All right, so big idea, we just have to show that two sets of angles in one triangle are congruent to two angles in another triangle. All right, so then, what I need is ideas. How can we show angles are congruent? Can anybody think of a way in which to show two angles are congruent?
Vertical angle.
Very good. Okay, so one method is that we know that vertical angles are congruent. What's another method?
The corresponding thing.
Oh, very good. Corresponding angles are congruent. Okay, remember that's when we have the parallel lines. Anybody think of another one?
The alternate angles one.
Okay, doing good. Alternate interior angles are also going to be congruent. And there is a possible fourth one.
The consecutive thing, right?
Well, consecutive is supplementary, not congruent.
Same thing.
Not even close.
Reflexive.
Reflexive, very good. Okay, so number 4 is reflexive property, as in if we can show that a triangle is the same angle for both triangles, then that shows the reflexive property. Okay? All right, so let's go and look at the very first example here. Okay? Our goal is to determine whether or not triangle ABE is similar to triangle ACD. That's the question. So if it is, give me two sets of angles that are congruent to two angles in the big triangle. So go from the top, one on the top to the big one. What do you got?
Wait, I just have a question. The squiggle, like in between, is like they're similar.
That means similar.
Okay, that's
Okay, so remember how like congruent, okay, use the equal sign with the, what you call the squiggle, okay, just the squiggle all by itself is similar, okay? So can anyone come up with two angles that are congruent? Yep. A is congruent to A. Okay, what property allows us to say that A is congruent to A? That's the reflexive property. Notice that it's in both triangles.
And the two lines are congruent.
Lines are not congruent.
They're something. They're parallel.
They are parallel. That helps us, yes?
Which means that B and D and E and C are interior, alternate interior.
No, not, because remember, in order to do that, you need that Z. Yeah.
Angle AEB is congruent to angle ADC.
All right. Noah said that he used 3 letters. He said AEB is congruent to ADC. Okay, and why are those two angles congruent to each other? Can you come up with a reason? Come up with? Begins with a C. Corresponding. Okay, those are corresponding angles, and that's why they are congruent. Now, we can also show that the other set of angles are congruent, but we don't have to. Okay, as long as you can show the two are done, You're good. So we can say yes, the two triangles are similar. Okay?
You only have to show two here?
You only have to show two. Okay? And the reason you only have to show two is we talked way back when about something called the third angle theorem. Do you remember what the third angle theorem was? No? Okay. So the third angle theorem talked about this idea that if I gave you two triangles, okay, and this top angle is 50 degrees, this top angle is 50 degrees, and this bottom left angle is 70 degrees, and this bottom left angle is 70 degrees, what's true about the third angles in both triangles? Why do they have to be equal to each other? And what's true about the sum of the angles of a triangle?
180.
180. They have to add up to 180, so therefore 180 minus 50 minus 70 is 60. 180 minus 50 minus 70, if I do it again, am I going to get a different number? No, I'm going to get 60 again, so therefore the third angles have to be congruent, given that the first two are. But, so we don't have to show that the third angles are congruent. We can go based upon just the two. Okay? So good question there. All right? Second one here, with the LMN and the OP. Can I show that I have two sets of angles congruent?
Yeah.
Yeah? Right? Give me a reason or a set of angles. Yes?
LMN is congruent to PON.
Okay, why are these two angles congruent?
Zero alternate interior.
They're alternate interior angles. So here's that Z concept. Remember, if we said, if you can make that Z, the corners of the Z are equal to each other. That's the alternate interior angles. Okay, now I need another set of angles. Okay, we've got the vertical angles are congruent. Okay, we've got two sets of angles that are congruent to two sets of angles. So therefore, are the triangles similar? Yes. And if I ask you to write a similarity statement, I would be saying, write triangle LMN is similar to triangle PON. And reminder that the corresponding angles have to be in the same spot. L is congruent to P, M is congruent to O, N is congruent to N. All right. Third one. Can I show the triangle on the left is similar to the triangle on the right?
Yeah.
Okay, I need two sets of angles that are congruent.
Angle F, or angle CFD,
CFD is this right angle, yes?
and angle DFE.
DFE, so the one next to it. Okay, so that's one set of angles that are congruent because they're both 90. Nine.
It's the same triangle, but it's flipped on its side.
Okay,
So angle F.
but we want to show that this angle on the left is similar to the triangle on the right. So we're not comparing it to the big triangle. You got an angle?
Angle C and angle D.
Angle C and angle D. Well, there's three angles at D. So what angle do you mean at
Just
D?
the angle FDE.
FDE?
And
So
FC.
what's the measure of FDE?
32.
32. And how'd you get that?
Because like Colin said too, it's like you rotate the angle sideways.
But
It's
how do we
like the
know it's
90
not
degrees, like-
22 or 42 or,
Oh, because 90 plus 58,
there you
and
go.
then you subtract that by 180, and
Alright.
that gives you 32 also.
Very good. Okay, so we've got two sets of angles that are congruent to each other, so therefore the triangles are similar. You do not have to show that this one up here is 58. Okay, it's not wrong if you do, you don't need it. though,
I know that.
Okay, when we finish. Okay, questions there? So again, we can say yes, the triangles are similar. All right, so now if I go back to the one that we had earlier with this picture, and if I took away the parallel lines, can I show that the two triangles are similar?
No.
Why not? You've got reflexive.
Actually,
That's the only angle that we can show that is congruent,
Yeah.
and you always need two. All right, so very good. Okay? All right, go on to the next page. All right, so now what we're gonna do is we're gonna use our idea of AA, and we're gonna take what we learned earlier in the chapter, so that'll take a little bit of review, and we're gonna use it in order to find a missing value. Okay, so it talks about a flagpole that casts a shadow 50 feet long. So I'm gonna draw my flagpole. Okay, and it casts a shadow 50 feet long. At the same time, a woman is standing nearby who is 5 feet 4 inches. So here's our woman. Okay, she's 5 feet 4 inches, and she casts a shadow that is 40 feet long. The question is, how tall is the flagpole? And they want it to the nearest foot. Ideas. All right, so what we gotta,
I know.
you know, okay,
Because the flagpole is gonna be 90 degrees, right? Because it's like straight up,
okay,
which means that you can add. Wait, I was going somewhere with that.
okay. The woman is also gonna be standing straight up and down, so she's got a 90-degree angle, so therefore we've got one set of angles
The other one
congruent.
is 10, right?
You've got reflexive here, okay, so you've got two sets of angles that are congruent. So the two triangles are congruent. So now the
Oh,
idea is to
but-
find how tall the flagpole is. So we need an X here. The goal is to solve for X. Ideas. All right, so a quick review from before we left. Okay, so if I gave you two triangles that are similar, okay, and if I said X is to 5 as 3 is to, I don't know, 10, how would you solve for X? Cross multiplication, so that means you need to set up a proportion in order to do that. So ideas,
Yeah.
what would you do in this case?
Oh, x over 3 and 5 over 10.
Okay, what do you guys think?
Yep.
All right, and then we can cross multiply and solve. Okay, all right, so that's the idea. Okay, so we're gonna go back to the example that we just drew with our flagpole. Can someone set up a proportion so that we can cross multiply? Remember, when you do that, you just have to match up the same parts. Be consistent.
Isn't it so x over 5?
Go ahead, Amanda.
Yeah, well, I was thinking x over 50 equals x over 40,
X over 50 equals what?
x over 40.
Not X, can't use X again, you gotta use 4 different things. So we used the X, we used the 50, we used the 40. What didn't we use?
The 5 foot 40.
All right, so if we did height is to shadow, height is to shadow. So now we're being consistent, so we've got 5 feet 4 inches over 40. Okay? All right, now before we cross multiply, the question does ask us for us to do this to the nearest foot. So can we change 5 feet 4 inches to feet?
Oh, no.
What's 5 feet 4 inches in feet? Is it 5.4?
5.3.
Why is it 5.3? And it's not necessarily 5.3. About. Why is it 5.3 and not 5.4?
Because a foot is 12 inches.
Okay, so how'd you get the 3?
These are
All right, so do you agree that 4 divided by 12 is the same thing as 1/3? All right, so then we can change this to 5 1/3. And now we're in feet, okay? Everything's in feet. We've got 5 1/3 feet, 40 feet, 50 feet, and therefore when we cross multiply, we'll have X in feet. All right, cross multiply, solve, tell me what you get. So you got 40 times X equals 50 times 5 1/3, which is what, 266.6 repeating,
That makes me
right? Did anybody get X?
Yeah.
What'd you get?
6 2/3.
6 2/3 feet.
Okay, but that's like a really awkward height for a flag, don't you think? Like, why was it? It's
It
just like,
probably is, yes,
it's
because it would
super
probably
awkward,
be higher, like 15, 20 feet.
it should be.
Yes, okay?
It's so weird, like,
It's just a word problem, it's more just in terms of making sure we understand how to solve, you know, missing values of a triangle, okay? All right, so
Alright, I got it.
no, you don't.
if we
Oh, wait,
change
never mind.
the question, so now instead of the woman, we have a child that is 58 inches,
410.
okay? How long is his shadow, okay?
I'm 5'1".
Yo, why is my 5-foot Christmas tree taller than you?
Oh, exposed.
All right, stop. Okay, so we've got the child here who is 58 inches, and we gotta find his shadow. Now, on the other triangle, we can either use the woman and her shadow, or we can use the flagpole and their shadow. What do you wanna use?
Yeah, I think the woman.
All right, so we said that's 5 1/3 feet, and her shadow was 40. All right, so like we did before, the first thing we should probably do is change the 58 inches to feet. What's 58 inches in feet?
410. Or
Okay,
4 and
feet.
5, 6.
Well, we want feet, so we want like a decimal, like we did
4, 5,
before.
6 feet.
So how do we change 58 inches? What's a quick way to get it into feet?
4.4. 4.5.
Divided by 12, so what's 58 divided by 12?
4.5.
No, it's not.
It's not 4.5,
4.8.
is it 4.8?
4.833333.
4.83333, which is what?
I mean, I know where
4 and 5, 6? So it's 4 and 5, 6. Okay? All right, which you said is 41, 6?
Yeah.
Is that what you said, Simran?
Yeah.
Yeah, 41, 6 is the same thing as 4 and 5, 6. All right, so now we can cross multiply and solve. We've got 5 1/3 is to 40 feet for the shadow, as 4 and 5, 6 is to x in terms of the shadow. Cross multiply, solve, tell me how long his shadow is. What'd you get?
36 1/4 foot.
How much?
36 1/4 feet.
36 and a quarter?
Yeah.
Yeah.
Okay, very good.
Wait, so how would you measure your head next to that kind of flag? Since it's not 90 degrees upwards? I didn't know this.
What do you mean?
Like,